Hello students, welcome to my channel Agriculture Engineering Online. This is a problem from GATE 2013, question number 54 and question number 55, common question. There is a statement: in an experimental setup, the discharge through a triangular nose is 0.0074 meter cube per second at an operating head of 0.1 meter. The coefficient of discharge for the nose is 0.7 if the required discharge is 0.1 cubic meter per second. The question number 54 is the corresponding head in meter is 4 options are given, and second question 55, the corresponding width of water surface in meter is dash. So let us quickly go to the solution. This is a very easy problem actually. So just if you know the trigonometry and the general equation for the triangular nose, then you can just solve the problem. So first of all, if you see the triangular nose, so it's a shape is the triangle, and also if you see the height or the head is h, let it be, and theta is the angle of the triangle, and you can make it the width of the, let it b is the width of the nose. In this case here actually depending on the head of the, in this case let it b, or this one is b, you can say. So b is depending on the height of the or water head. In this case, first of all, the discharge by a triangular nose is let it q. The general equation is q is equal to 8 by 15 cd s to the power 5 by 2 square root of 2g and tan theta by 2. So in this case angle is this theta. This is the theta is the angle between the two edges. So this is the general equation. If you know, first of all, it is given in the experimental setup, number of experiments are done at different discharge and different head, then you can calculate the general equation. First of all, the q is given. So in this case let, actually it is not required. In this case, the what are the equation, that is this if you don't remember also the how much 8 by 15 or whatever, so you can just easily calculate from the ratio. So first of all, the discharge 1 is given, q1 is given, that is 0.0074 meter cube per second at a head of, let it h1, that is 0.1 meter. This is the head, and the head is given. So discharge you have to calculate. So in the first case, so q2 is you have to calculate, and at a head of, let it s2, that is, sorry, the q2 is given, that is 0.1 meter cube per second, and head you have to calculate. So in this case, so therefore if you see this one, the equation, so q is directly proportional to h to the power 5 by 2, and if other things are constant for the same node, then you can say q is proportional to h to the power 5 by 2, since cd is constant also for the same one. So therefore q1 by q2 will be equal to h to the power h1 by h2 to the power 5 by 2. So q1 is given, that is 0.0074, q2 is 0.1, should be equal to h1 is 0.1, and h2 you have to calculate to the power 5 by 2. So by solving, so taking the root of this side, so you can get, that is 0.1 by h2 will be equal to 0.353, or h2 will be equal to 0.1 divided 0.353, that will be equal to 0.283 meter. So this is the first question number 54. The option is C, you can say. Now coming to the second part, that it is asked for same discharge, that is 0.1 meter cube per second, that is head already you calculated 0.8283, you have to calculate the width. So very simple, from the geometry, if you see, this is the triangle, so this is the triangle, you can see, and width you have to calculate. So if you divide it, so theta will be, this is theta by 2. So in this case, then this is b by 2 and this is also b by 2, from this to this to this, and h is given, so this is h is 0.283 in this case. So if you know, then from this triangle, so like this triangle, so this is b by 2, this is theta by 2, and this is 0.283 is given. So you know that is 10 theta by 2 will be equal to b by 2 divided by 0.283. So this is the equation. So now 10 theta by 2 you have to need to require to find out. So for this, so just put the equation, 0.1 will be equal to 8 by 15, so into 0.7 is given the CD, so coefficient of discharge is given 0.7, 0.7 is given, therefore you put this CD, and H is now we calculated, that is 0.283 to the power 5 by 2, and into square root of 2 into G we take 9.8 and into 10 theta by 2. So 10 theta by 2 we have to calculate, therefore everything is known. So therefore 10 theta by 2 will be equal to, so 0.1 divided by everything, so therefore it will be 1.42. So once you find out the 10 theta by 2, so this can be equated here, that is 10 theta by 2 is equal to b by 2. So 10 theta by 2 is b by 2 divided by 0.283, or 10 theta is 1.42. So b by 2 will be equal to 1.42 into 0.283, and b will be equal to 1.42 into 0.283 into 2, that is will be equal to 0.804 meter. So this is the width required, that means water surface, this is the water surface width in here, in this case, second case. So therefore the answer will be, option is given, there is 0.80, so the answer will be A. So first case the answer was C, the question number 54, and second question, that is 55, which answer is A. So this is the answer, C and A. Hope you get the answer. Please like and subscribe to my channel.